How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a dog bone off a 785 dump truck in for repair. So this is a linkage that holds the rear diff to the chassis of the truck and holds the diff in center while the truck is in operation. So it's really important that these components are in spec and don't have any wear. But this component does have wear in both bores, and that is to be expected just because of the nature of this machine and what it does. So on each end of the bar there are spherical bearings, and they do allow free movement between the diff and the chassis, but over time the bearings start to wear out the bores and they end up loose like this one. So these are in no means really bad condition. This is still in pretty good shape, but the customer is doing a midlife or a rebuild on this truck, so they want everything to be back to standard before it goes back to work. So what we're going to be doing is reclaiming both of these bores back to spec. So we could definitely set this up for line boring, but because it's a nice flat component, we're going to be setting it up in our Zaya bed mill. But before we set it up, I'm just going to grind off this paint. It is quite thick and I want a nice flat surface for this to sit on. So I am going to do just a quick weld test just to make sure we are able to machine the weld after we've welded it. A lot of these components are manufactured in different facilities all around the world. Typically these components are made from cast steel or a piece of plate, but depending on what the material is will depend on if you can machine the weld. So it's very simple. All I'm going to do is put a small tack on the edge of the component and see if we can file it. So as I expected, it has passed the weld test, so now we can go set it up in the Zaya. So to give myself a little bit of clearance, I'm setting this up off the bed and I'm going to be using some Highwind rail offcuts. You might remember these from our Toshiba milling machine that we scrapped. These are perfect for this because they are precision ground and they offer a lot more support over a 123 block. And I'm going to be securing that to the bed using M20 toe clamps. Now with that set up, we can get our first bore centered. So we do have the convenience of this being in really good condition, so we are just able to use our edge finder to locate the center of the holes. If they were severely damaged and you weren't able to locate the center of the hole, there is a salvage procedure with all the specs and measurements, so you can reclaim this part. Now that that's centered, we're going to set up the tool. We're going to be using our shop-made adapter with our Walhopter boring head. So I'm going to be using an ECGT insert. These are fantastic for this sort of thing. We also use them for line boring. I'm just going to eyeball my start position and then I will advance from there. So now we're set up and we're going to take our first cut. So one of the problems using this style of insert is you can't feed them too hard because you will break them. So we are running a low feed rate, but that results in stringy swarf. All we do is just let the machine run, stand out of its way until it finishes its cut. So in my experience, if you don't machine out enough of the parent material, you end up machining away a lot more of the weld layer. And because the weld layer is so thin, you do run the risk of running into hard spots and you end up with a really bad surface finish. So even though the first cut cleaned up the bore, I am going to take a second cut. That way I'm going to have a good thickness of weld material when I go to machine this back to spec. So that's our first cut done. I'm just going to slow down the RPM a little bit. I'm then going to advance the tool one more mil and take our final cut. So one of the other benefits of using the Xaya, not only is it fast to set up, but it is far more rigid than using a line borer, which means boring it is about 5 times faster. So that's our first side bored. I'm not going to move it over to the other hole just yet. While I've still got the boring head set up in the center of this bore, I'm going to fit on my bearing mount for our Sermocanica so I can bore weld this. So to set up our bearing mounts, I'm going to be utilizing the head of the machine. I've got a side lock arbor with a piece of 40mm bar in it, and that suits our bearing mounts for our line borer perfectly. That way I can get the bearing mounts perfectly in center and level with the job. So that's our mount in position. I'm just going to tack it in place. So now we've got that done, we're going to get it set up to bore the other side. So that's our second side board. Now we're just going to set up the bearing mount. So now we're ready to set up the Sur Mechanica for bore welding, and we're going to be bore welding with the part still secured to the bed. And the reason I'm doing that is going to prevent two more setups where I would have to take this off the mill, set it up in the welding area, bore weld it, then I would have to bring it back and dial it all back in again to finish bore it. So it's definitely going to save us a lot of time, and I am going to take the precautions needed in order to protect the machine from the welding process. I'm going to slide the bed down as far as I can away from the head. Because the job is elevated off the bed of the mill, there's not going to be any heat transferred into the bed. I'm also going to be using leathers to cover the bed so no splatter gets on anything. I'm also going to isolate the machine and turn everything off and earth directly to the job. So I'm sure there's going to be people out there that completely disagree with what I'm doing, but that's the beauty part about working for yourself. I get to make my own decisions. The filler material I'm going to be using is ESAB copper free in a 0.9. The gas I'm going to be using is Argo Shield Metal Core. That's 90% argon, 10% CO2. I'm going to run that at about 19 volts and 4 meters of wire a minute. So I'm expecting to see a bit of weld spatter on these first two passes. That is because I am welding into a snap ring groove. If I was to machine the snap ring grooves all the way out, that would mean I would have to put 2 layers of weld back in there. So I'm not overly concerned about that because I am going to be cutting in new snap ring grooves anyway. So you will also notice that there is spatter as the weld passes a grease hole. That is unavoidable, it's going to happen. All we do is let the welder continue to run, and then when we're finished, we re-drill that grease hole.
Oh, come on in. Come on. Come on. Come on. Run, run, run. Hey. There we go. Okay. Come here. All right, that's it. See ya.
So there are so many variables that come into play when you are bore welding. Not only do you need to consider your feed rate and your rotation speed, other things come into play like gravity, the diameter of the bores, the temperature of the day, and how much weld you need to put back in there. So I'm keeping a very close eye on the first two passes and making fine adjustments in order to get the best weld layer possible. Something else that can come into play, and I have noticed, is the demand on the power grid in this industrial estate. There are some days when across the road will fire up their big roll formers, and I can feel and hear the difference in the bore welder while it's running. But if I'm working late at night or on a Saturday when the other workshops are closed, I can set that machine to its standard parameters and not have any trouble while it's welding. So it's definitely taken a lot of trial and error to gain that experience. So that's our first bore welded. Now I'm going to get the line borer set up on the other side. There we go. So that's this side also welded. I'm really happy with how those layers came out. Everything looks nice and uniform, and it's going to be nice to machine. So now we're just going to let this cool down for a while before we can get back onto machining it.
Oi, hey. Where's your toys? Come on, where's your toys? Go find him. Where'd you go? Oh my god. Whoa. Alright, see ya. Good boy. Oi, good boy, bring it here. Get out of the bin. Oh my god. Come on. Yeah, sit. Sit. Come here. Whoa, sit. Spin around. Lay down, roll over. Oh, good boy. Oh my god. It's all gone. That's it, no more.
So everything's cooled off enough now. I'm going to disassemble the ball welder. We can get back onto machining. So all I need to do is travel the bed back to its 0 position, then I can bore the first hole. So that took less than a minute to get that back into position so I can start boring it. If I'd have taken it off the table, I would have had to come back and reset everything back up again. So I'm just going to slow down the RPM a little bit, and I'm also going to reset the tool for our first roughing cut. So that's our first roughing cut done. Before I do my final cut, I do need to do some touch-up welds around the snap ring groove. Because the weld didn't build up quite thick enough there, it has left a bit of a hollow. So we're going to touch them up and then we can finish it off. So now that that's welded, I'm just going to run the boring head back down to take off all these high spots, then I can measure it. So we've still got 0.7 of a mil to come out. I'm not going to take that in one pass. Because of the nature of these boring heads and the way the tools are, the swarf does have a habit of building up around the tool, and that can actually push the head to the side, and then you end up with a tapered ball. So we'll take out 0.5 of a mil, and then we'll take out the final 0.2 on the last cut. So that's our first hole bored to size. Now I need to machine in the rest of the details. First thing I'm going to do is machine the top flat, put a chamfer on it, and then we're going to cut the snap ring grooves. So to do the chamfering, I'm just going to change out my tool to a neutral CCGT insert. And to cut the snap ring grooves, I'm going to be using a Walhalpter extension and a shop modified parting tool. So I am probably asking a lot out of this setup. There is a lot of tool stick out, so I'm probably going to end up with a lot of deflection and some really terrible noises, but we'll see how it goes. If I have to make any changes, we will. Yep, still set. Here we go. Oh.
Yep.
So that is cutting, but there is a lot of vibration and a lot of terrible noises. All I'm going to do is end up breaking the insert. So I have made some changes. I got rid of that longer extension and put two smaller ones in its place, which is going to offer a lot more support for the parting tool. So that's our first snap ring groove cut. We did run into a little bit of chatter, but that is to be expected. I am trying to use a 4mm parting insert. Snap ring grooves can give you trouble at the best of times, but we've got that one done. So I'm going to lower the head to cut the second groove.
Whoa, whoa.
That's why I wanted the long one.
Do you have enough clearance?
Yeah. Here we go.
Oh, yeah.
Righto guys, so that's our second groove cut. We've got this end completely machined. What I'm going to do now is move the table across and get set up for our second bore. Just push the yellow button on the top. There you go. So press half and then X. Righto guys, that's our second hole machined. I'm going to take it out of the mill, back over to the welding area so we can grind off the tacks and drill in the grease ports. So before we fit the bearings, I'm just going to install the bottom snap rings.
Oi, 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 oi. Jesus. There we go.
Righto guys, so that's this repair completed. For less than a day's work, we've saved our customer a lot of money. To replace this linkage is actually $7,500, and that doesn't include the snap rings or the bearings. So this one's ready to go back to the customer. Thanks for watching. Right, ready? But that was awesome. So to set up our bearing mounts, I'm going to utilize the machine. Am I?
I'm just getting comfortable.
Right.
I'll be here a while.
So what this is... spherical bearings. But...
Because it sounds like you're not even hearing what's coming out your mouth.
So the first couple of passes, oh my God.
What happens?
Got
Is
it.
there a reset?
I don't know. Ready? Got it. Right, I'm gonna start again.
Okay.
Right.
Is there grease in it?
Yeah, someone was greasing it.
Oh yeah.
It's unusual.
Ew! That's nasty. Whoa. Is that a bit much?
See a wall.
Yeah. Someone made this thing too heavy.
Yeah, you did. He's a strong guy.
And that bolt too long.
It's not too long.
How many washers have you got up there?
6. Push the red button.
Which one? The stop or that?
That one.
This one.
Bang!
You're pointing to the two of them. What? Oh, that's the liner. Wasn't that the liner you just cut?
Whoops. I can't see it.
I could.
I couldn't. I can't see it. It's fine. It's just a liner.
Oops. Oh yeah.
They just come in a roll.
Oh, does
You
it?
just cut the bits off as you need them. Yeah.
Huh. There you go.
Line?
What are you looking for?
Line to it.
Is it down one of the gaps?
Sure enough. So one of the other benefits, oh wait, what'd you say? So one of the other benefits, apart,
Oh my god, man. Use your brain.
I don't want to!
Oh.
Pretty cool, eh?
What, does it need reclaiming?
Yeah, both eyes. Attack, kill, destroy.